In this lesson, we're going to review a 30, 60, 90 triangle. 30, 60, and 90 represent the angle measurements of the triangle. So we have one angle that's 30 degrees, one angle that's 60 degrees, and of course an angle that's 90. An example of a 30, 60, 90 triangle would be to have one side whose leg is 1, a hypotenuse of 2, and another leg of radical 3. You could plug these into Pythagorean theorem and you'll see that it works. 1 squared plus the square root of 3 squared would end up equaling 2 squared. It's important that the 1 is across from the 30-degree angle. The 60 has the side measure of radical 3 across from it. And the 2 is the hypotenuse, opposite the right angle. Since it has this proportion, we could have any triangle that's a 30, 60, 90 be a multiple of these sides. So we could double this side, make this side 2, double this side, this will be 4, double this side will be 2 times radical 3 over here. Or simply, this side could just be multiplied by any number, so multiply it by x, we'll just get 1x, or x. This side would be multiplied by x, would be 2x, and this would be x radical 3. This is going to be very important in 30, 60, 90 triangles. So by knowing this, we could find out any of the sides if we're given one of the sides. So for our first example, let's say we're given that this side is 5. This would be the 30-degree angle. This is a 60-degree angle. Just from knowing this one side, we can find the other two sides. So the 5 is across from the 30. So let's look at our diagram. Across from the 30 is x. So that means that x is 5. This side, the hypotenuse, is 2x. So this side is simply 2 times x. So that's 2 times 5. So we get that this side is 10. This side down here is across from the 60-degree angle. And in our diagram here, across from the 60 is x radical 3. So that means this side is x radical 3. And we know that in our example, x is 5. So this is just 5 times radical 3, or 5 radical 3. So if we're given any of the sides, we go back to this diagram, determine what x is. In this case, x was 5, and we just plug it in for the other sides. So this was 5, so this became 2 times 5, or 10. This was x times radical 3, so we had 5 times radical 3, and we have all of the sides. Okay, now let's look at another example. We'll call this example 2. In this example, we're given that the hypotenuse is 4. We have to find the other sides. So first of all, the side we're given is the hypotenuse. It's across from the 90-degree angle. So look at our diagram. You see that it matches up with 2x. So that means this 4 matches up to 2x, so we have 4 equals 2x. So we just solve for x. And we get that. In this case, x is 2. So if we want to find the measure of this side, It's across from the 30-degree angle. Across from the 30-degree angle is just x. So that means this side is x. In our case, x is 2, so this side is 2. If you want to find the measure of this side, well, this is across from the 60-degree angle, and across from the 60-degree angle is x radical 3. So that means this side is x radical 3. And we solve for x. We know that x is 2. So this would be 2 radical 3. So we were given a hypotenuse of 4. From that we determined that x is 2. And now we're able to figure out the other two sides by using this diagram. Let's look at a third example. In this example, let's say we're given this side to be 4. So we first have to determine what x is, and we could figure out the other sides. So this side is across from the 60-degree angle. And across from the 60 is x radical 3. So that means we have 4 equals x radical 3. If we could figure out what x is, then we'll know the side opposite to 30 and the hypotenuse. So this is x times radical 3. So to solve for the x, we just divide by radical 3. So we have 4 over radical 3 equals x. Okay, we're never going to use this in our computations because we shouldn't have a radical in the denominator. We have to do something called rationalizing it. So in order to do that, we just multiply the top and bottom by the radical in the denominator. So we're going to multiply this by radical 3 over radical 3. So this becomes 4 radical 3. The denominator, the square root of 3 times the square root of 3, would give us the square root of 9, and the square root of 9 is 3. So we have x equals 4 radical 3 over 3. So now we have x, we could find the other sides. So let's find the side across from the 30, and we see that across from the 30 is just x. So this side is x, and we know that x equals 4 radical 3 over 3. So this side is 4 radical 3 over 3. The hypotenuse is 2x. So this side is 2x. So in this case it's 2 times 4 radical 3 over 3. Let's multiply this. 2 is just the same as 2 over 1. So we get 2 times 4 radical 3, which is 8 radical 3. And then 1 times 3 is 3. So this hypotenuse is 8 radical 3 over 3. This leg across from the 30 is 4 radical 3 over 3. And we were able to figure that out because this leg across from the 60 is 4. So this could save us a lot of time in solving for the other lengths of the sides just by using this proportion. So any side we're given, just set it equal to the side it corresponds with, solve for x, and we could find out the other sides as well.